autonomous vehicles need to not only detect, but act upon traffic light and stop sign rules in an appropriate manner as defined by the rules of the road that drivers follow in everyday situations. We claim that through the use of our constructed algorithmic logic and deep sort and object tracking algorithm, we can have autonomous cars that detect traffic signs and follow the rule of the road in an appropriate manner.
Final project, we needed to do object tracking in order to track the cars moving around in the queue and also the stop signs detection. So when we are doing this, we use an algorithm called deep sort, which utilizes something called a Kalman filter, which is a controller that basically helps us determine if we should keep tracking an object when they disappear and reappear.
For traffic light logic, there are three cases that we look at. First is the green light, where we will continue going forward and not stop. The second case is a red light, where we will stop until we see a green light to continue. The third case is yellow light, where we have also two cases. One is when we see a yellow light early, we will come to a stop, and if we see the yellow light late in our turn past the stopping line, we will continue. Finally, this is a more complicated case where we have to determine which traffic light to look at, and as you can see, we came to a stop at a red light and continued.
So in our stop sign logic, we basically start by object tracking and checking if we detect the stop sign. And when we detect the stop sign, we also check the stopping line. So when we basically change the state and we basically wait to reach the stopping sign. When we reach the stopping line, we take a picture of that object tracking and add all the possible cars and trucks we have seen to the queue. And then after adding all of them, we add ourselves. And after that, with every frame, we update our queue by popping all the cars that disappeared or like moving while determining if they reach the center of the screen using a peek function. After we pop them through the queue, when we pop from the queue, finally, we actually move the car and the car goes to the next destination point.
So here are a few more examples. This is a three-way, three-car stop, where the first car comes to a stop, then it is our turn to go, and then finally the third car will go. Here is a top-down view of that same exact scenario where the first car comes to a stop, continues, we come to a stop, and then continue, and finally the third car has stopped and continues. This is a scenario in which the car does not move. In this case, we will wait a little bit longer to check if the car will move, and if it still continues to not move, we will continue to go. Here's that exact same scene from the top, and you can see we wait for a longer time than we would at a stop sign. After verifying that the car does not move, we will continue.
A big takeaway that I had from 484 was the concept of reach and safety, where there's a number of unsafe states that are reachable from a starting state, and a simple way to reduce that is to reduce the range, but that could also decrease the utility of the system. So another approach was to instead increase the safety margin by decreasing the potential ways to reach that error. And we did this in our project by adding a bunch of additional qualitative analysis to our traffic light detector to ensure that the traffic light we were looking at was the exact one that we wanted.
In this class, we learn about the PID controls, other type of controllers during our control part of this class, which helped me understand the Kalman filter and helped me improve add additional components like collision checking. In addition, we also learned about particle filters, which helped me also understand Kalman filter better.
Hi, a topic that I found really interesting in this class was the object recognition lesson. Specifically, I found the statistical learning framework portion of this lesson to be extremely interesting. I found it was interesting because I think it's cool how you can actually create this prediction function, add in some feature representation into that function, and actually be able to obtain an output that is able to differentiate between features and different objects. The way that my group and I utilized this in our project was through the blob detection filter, where we used that to actually figure out if we were looking at a traffic light or not, and we took that one step further to determine what type of color traffic light we were looking at, utilizing the same type of feature and object detection algorithms.
I had a fun time in this class learning the many algorithms for self-driving cars and how to make them safe. Even though the MPs in this project were challenging at times, I really enjoyed figuring out the bugs and watching our car actually drive by itself. Through the project, I was able to use what we learned in class and incorporate our detection code and logic into Carla, where we could test specific scenarios that are applicable to the real world.